Hi, everyone. Welcome back to day 2 of Becoming a Hacker with Omar Santos. Omar.
Hello, hello. Thank you so much, everybody, and thank you, Neural, for the introduction. Welcome back. Yesterday, we a little bit of ran out of time at the end, so we're gonna pick up with a few things that we left off related to web application vulnerabilities and so on. But before I share my agenda, let me actually do the obligatory disclaimer from my side, right? So, and it is that the information that I'm providing here is for educational purposes only. Either myself or Riley or no other entity is definitely no way responsible for the misuse of this information, since of course the tools and the technologies that you will learn can use for good, of course, to find vulnerabilities before the bad guys do it, but of course the dual nature of technology and these methodologies, make it very attractive for attackers, and that's what we're learning here, how attackers use those methodologies and tools. But today we actually are going to go over an introduction to, well, first of all, we're going to catch up from yesterday, so for sure. Second, we're going to shift gears into network devices. So how attackers can manipulate network devices, the fundamentals of wireless hacking, and a brief introduction to buffer overflows, creating payloads, code execution, and so on. Then we're going to go over social engineering and then move to post-exploitation techniques. That includes evasion of defensive techniques, that includes command and control, exfiltration, privilege escalation, and much more. And then today we're going to conclude with a few examples and best practices on how to write penetration testing reports. You are very familiar with this GitHub repository. By the way, what I'm going to do is I'm going to share the screen because, as you probably already know, I drive most of my presentations through screen share and through demonstrations. So I want to take a moment, of course, to cover the things that were kind of left off yesterday. So if you were not here yesterday, what you're seeing in front of you is the lab guide from yesterday, and specifically we adjourned whenever we were about to cover cross-site scripting, cross-site request forgery, server-side request forgery, things like that related to web application vulnerabilities. And in the resource icon right now, you have a link for the lab guide of yesterday. Sorry, for the lab guide of today. However, Nurul was kind enough to put in the group chat. So if you don't mind looking at the group chat, there's a link to the that's the Google Drive, okay. But there's also gonna be a link, the official link from On24 and O'Reilly that is gonna be part of your recording, and then of course you can get those later in the in the day. You should be actually able to get the recording today from yesterday. But in exercise 12, that's whenever we were talking about proxies and what is a proxy. We talked about um, the OAZ attack proxy. We also talked about Burp Suite, and there are a few other ones in there. The ones that you are playing with these labs is mostly Burp Suite, but a lot of these techniques can absolutely be done using the free open source, a very popular tool called the OAS Z-Attack proxy. And we went over that yesterday. But what I want to do is, it says the link needs authorization. Okay, so I just see Neural. Unfortunately, that's the link for Google Drive. So stay tuned. If you were not here yet, if you were here yesterday, it's the same lab guide. If you were not here yesterday, then that's the lab guide that Neural is about to publish. It's just to give you access to the lab guide from yesterday. But if you were here yesterday, this is the lab guide that I'm actually presenting here. So you can use that. It's only for the people that were not here yesterday. Then the lab guide that we had it allotted for today, which we will still cover in the next few minutes, that is already posted in your resource icon. So feel free to download that, and of course the slides for today. So thank you. All right. So basically, the elements of web application hacking, as I mentioned yesterday, is first is to truly understand how applications work. And then you can use tools like a proxy. And let me shift gears to at least this slide. Give me 1 second here. Let me go back. But yesterday I mentioned that web proxy is a software, a piece of software that allows you to intercept the transactions from your web browser to the web application for the purpose of modification, analysis, and recording of those transactions, and for the purpose, of course, for finding vulnerabilities or misconfigurations. So it's not only about the request, right? So we're talking about web applications here, so it's a request and response, but it's also the response, right? And how that can potentially affect the client or an API, right? A lot of people think that it's only about testing, what a browser is actually doing to a web application, but it's absolutely not. You can actually do this in combination of other tools to absolutely evaluate API implementations, right? Now, what I want to do is actually go over some of the most popular vulnerabilities that we have in here. And one of them, of course, is cross-site scripting. So remember yesterday, we went over the OWASP top 10. And the OWASP top 10, for those of you that are not familiar, very, very quick, since we covered yesterday, it is the top 10 risk against web applications. That's the one of the list that they have. Now they also have a list of the top 10 risks for mobile applications, for IoT, and even LLM, so AI-based applications, generative AI driven applications. So, but the ones that we are gonna concentrate right now, and we're gonna, time permits, we're gonna deep dive into a little bit of the AI one. It's of course the web application vulnerabilities, and one of the things is that list, most of them is a list of categories, and then you have injection, broken access control, you have things like you know, cryptography issues and so on, right? But the different categories, the only one that actually has its own category is server-side request forgery, which we'll actually cover a little bit later. But one of the most popular that has always been in the list for quite some time, talking about over 10 years, is cross-site scripting. And you may think, okay, so that's a problem that actually has already been fixed, and we should move on, and that's not applicable anymore for web applications. Well, think again. It is still a problem nowadays. It is still a problem in the age of AI. It is a very hard challenge, because at the end of the day, it's input validation. So if you look at cross-site scripting, there are three different types of cross-site scripting: reflected, store, and DOM. The reflected and DOM-based cross-site scripting basically is a type of reflected cross-site scripting. Anyways, they are non-persistent. That means that if an attacker wants to launch an attack against that application and against the user, then they need to either fool the user to follow a malicious link with a payload, with a JavaScript embedded payload in there, or they will have to actually, of course, inject the payload somehow through the process of the user visiting the application. Then the other difference is, of course, a little bit of the social engineering, right? So that you have to do it. Typically with cross-site scripting, in most, not all, but in most of the attacks, you have a social engineering component to it. Now, stored, which is the one here in the middle, right? This is just like the word says, a flaw, an input validation flaw, that if an attacker is successful to inject or fool the user to inject some malicious, JavaScript into something like a web form and so on, into the process, then that payload gets stored either in a file or in a database, making it persistent. So in other words, if a user then visits that URL or that specific portion of the web application that is susceptible to cross-site scripting, then they don't have to, be fooled to follow a malicious link or have a payload or do the social engineering. Anybody can potentially get um, affected. So what is being affected? Well, this attack includes things like session stealing, like you stealing the cookie of a browser to then potentially even bypass multi-factor authentication and so on. It can also be done for account takeover. It can be done in the case of DOM-based cross-site scripting for DOM node replacement or defacement, like Trojan login panels and so on. And then attacks against the user browsers, like downloading malware, keylogging, and other client-side attacks. By the way, since we're mentioning the client, this vulnerability, I'm going to put here A for attacker. So the attacker, yes, it finds a vulnerability in a web application. I put here W for web application. But the victim itself is the client, and the C is for client. So once the attacker finds a vulnerability in the web application, and of course this is what you exploit and fix, then it either fools the user again to somehow put a payload for injected cross-site scripting. And you're gonna see several examples, actually many examples in the next few minutes. And then the client is the one in most cases that is the victim, right? Because then that's where you can do session stealing, steal your cookie, redirect you to a malicious site, account takeover, multi-factor authentication bypass, and so on. So once again, the vulnerability, of course, is in the web application. In most cases, the victim is actually the user. Right? All right. So where do you find cross-site scriptings? You can find them in search fields that will echo a search string, and you will see that in the lab guide or in your lab. In input fields that echo user data, in error messages that return user supply text, hidden fields that contain user supply data, and much more, right? In other words, if you're not sanitizing data within any user expose, like a search field or a form that has an input field or a hidden field behind it, you can absolutely potentially manipulate that, right? Tons of examples. Again, I'm going to be briefing here because you're going to go over and do this by yourself. Now, let me go over to your lab guide because I want to introduce another thing here. Remember yesterday we started talking about broken access control. That was actually in the top of the list of an application and so on. You have exercise 12 that starts with a little bit of reconnaissance, fingerprinting, web frameworks and so on. But the purpose of this exercise is for you to become familiar with that proxy that I mentioned to you, burp proxy, because you will need it for many of the other exercises in here. So everything is step by step. So you click on proxy, there is a built-in proxy within Burp Suite, right? So this is the open source, not the open source, but the free, the community edition version of Burp Suite that we're using here. There's a professional version that has additional information or additional features rather, like automated scanning, built-in payloads, a lot of integrations with tools, and they're adding features all the time. Things like Collaborator, which is a command and control. Burp Suite Collaborator is a command and control looking feature or capability within Burp Suite. That is not included here, but Burp Suite goes beyond of a proxy. However, in this exercise, you gotta become familiar with the proxy implementation of the web app, of Burp Suite, and also that you're gonna be playing with the intruder. So this first section of the exercise, again, everything is documented with screenshots, like click here, number one, number two, as you see in the screen, and so on. Uh, Burp Suite includes a built-in browser. That's the one that I always recommend. It's easier to use than an external browser. But if you want to also use, let's say, Firefox, right? I did include some instructions on how to go to network preferences, of course, go to the network proxy settings, and then point the proxy settings to the local host, so 192.168.0.0.1 on port 8080. However, if you do use, so again, I'm highlighting this because people can get confused, but if you use the built-in browser, you do not have to go through all this process. You just click in this number two here that I have, and that will open Chromium, which is the built-in browser of Burp Suite, right? For most people that either this is your first time or you're just looking for convenience, this will be the method that I will recommend, right? But if you want to get familiarized with, how to actually point to a proxy and so on, definitely, explore with Firefox, if you will. Right? However, once you do that, there's a web application in Websploit that is relatively old. Uh, However, the exercise is still relevant to today, and especially since cross scripting is still relevant. Later, you're gonna go into a lot more complicated things. But there's one called DVWA, the Damn Vulnerable Web Application, and I don't want to offend anybody. That's not my name, but it is it is the name of it. So whenever you log in, and again, you have very prescriptive information. You're gonna go to 10.6.6.13. The default username is admin. The password is password. Then you get access to this. You can reset the database. It should be already reset for you whenever you set up WebSploit. And then it walks you through proxy, the intercept section or the icon for you to intercept and capture the packets or the transactions between your web browser. And I have a lot of different pointers and references to their documentation that goes way beyond. For the purpose in here is for you to get familiarized with the proxy, right? So that's the first section. It asks a couple of questions, but that's the main purpose. The second purpose, even though the title says brute forcing the application, and if you probably think, okay, brute forcing is an attack of 1999, right? So this is an old type of attack, and the answer is yes. But guess what? People are still using it right now, and they're very, very successful to compromise very critical places. But besides that, let's go beyond just brute forcing. Go over and understand the process for you to go and then navigate through Burp Suite and then get a payload. Basically, you're gonna go and set the security and so on, but you're gonna get the transactions from your web browser in this case, right, to the web application, intercept that. Yes, you're intercepting the username and password that you change. However, look at how you can use the intruder, and we're gonna go into details on this, and then essentially manipulate the fields, right? So you can clear positions, you can manipulate the fields, you can use your own word list if you want, you can create your own. That is the methodology that I want you to actually concentrate. Vulnerabilities will come and go. As I mentioned yesterday, tools will come and go. The methodology of actually putting everything together, that's what I want you to actually understand in here. So let me pause for a second because sorry about that. I pressed the wrong button. I got too excited and closed the tab of my of my browser. I disconnected. So let me connect again. I was about to say, let me pause for a second and address a couple of questions that came in the Q&A panel. So first, MR says, what are my options for labs for Mac? I would like to finish the labs. if you have a Mac M1, M2, you have to use, it will not work out of the box. You actually have to use either a system with Proxmox, VirtualBox, and so on. The problem is not the VM, what you're installing, is the containers, right? They're actually used or they're created for x86. And most of the the free labs that you're going to be actually looking, across the internet, unfortunately, is there. There's tools that allows you to convert those containers. All these containers, if you actually download the install script, you will see them in Docker Hub. You can absolutely convert them, but we only have that version in here. Now, PK asked, lots of recent antivirus, EDM endpoints protections, and even browsers are well protected from cross-site scripting. Is that enough for protection from this point? Do we need to have extra devices like WAF? The short answer is, even including WAF, there is no end to this problem. Yes, there's a lot of protection in place, but also there's a lot of obfuscations in place, which is actually an amazing question that you asked, PK, and thank you for asking that. Let me share my browser without clicking the wrong button here. But if you go to my GitHub repository, again, you have the links. If you were not here yesterday, you get it here today, and so on. They're in the lab guides, they're in the slides, everywhere. Is hackerrepo.org. It will redirect you to this page. And then if you go under web application testing, I got a few things around server-side request forgery, SQL injection that we're going to explore a little bit later. Excuse me. However, if you click on XSS vectors, so cross-site scripting vectors, you see a lot of them in here. And this is just an example. There are 673 lines. So I think the first one is just the title. So essentially, there are 672 different ways that you can potentially bypass a WAF, that you can potentially, or can definitely bypass a lot of the protections that are in place, because again, the input validation of this is a hard problem. Now, yesterday, let me pull it up real quick. Yesterday, we cover, in your slides from yesterday, there's a link for this, and also in your lab guide, I believe, the cheat sheet series for OWASP. There are definitely a lot of recommendations that also talk about built-in security for your browsers, etc. But they talk about the filter evasion cheat sheets. Basically, it goes over for both the ethical hackers to mimic what an attacker can do to bypass the protections that are in place by browsers, by WAFs, so WAFs. By the way, I'm mentioning that is web application firewalls. That's what PK refers to. But they have tons and tons of examples of even that I do not have in all that big list that it can potentially bypass. And then, of course, at the end, because it's pretty comprehensive, they have a lot of recommendations of what are the things that you should do and filter within your environment. But as you see, this is insanely comprehensive. So the short answer is yes, still a problem. And that's why you see this very, very comprehensive either examples or sort of guidance in the industry. And just to make it, I guess, fair for everybody, even though it was in the lab guide and the slides from yesterday, I'm pasting the link to the group chat. And by the way, I just saw your question too there, PK. So that 10.6.6.13 is IP address inside the Kali where we install WebSplit, correct? Yes, indeed. Everything that you will see, like the 10.6.6 network, actually, that's perfect. For those of you that were not here yesterday, you do have to catch up a lot, but it is not mandatory. Again, I'm giving you this as homework. You can complete it here today. If you're just coming in and trying to catch up, and install WebSploit Lab, it's going to be a little bit overwhelming because we're going to be starting to give some breaks for the exercises of today and a few of yesterday. But um, everything that you are going to be referenced here with an IP address is part of this WebSploit environment. How do you set it up? You download Kali or Parrot in your own environment, whether you want to put it in the cloud because you're running into compatibility issues with hypervisors and things like that in a Mac, or in your personal PC with VirtualBox, or a dedicated system with Proxmox. It all works in that respect. The only compatibility problem is, of course, the predicament with Mac M1, M2s. But you run this command, you will install Docker, and you have a lot, and I'm talking about a lot, of different containers and exercises in here. So, for example, just the one that we were talking about, which is DWA, the 10.6.6.13, that has, I don't know, probably about 20, 25, different exercises. UShop has about 60 plus. And then the ones that I created on the right, some of them they have two, some of them they have, is a complete set of vulnerabilities that, as a matter of fact, you're gonna be using the bottom three here today. Um, the lab guides that are allocated for today is for you to actually do a lot more of the exploration of from reconnaissance and not knowing anything about the application, all the way to getting root access or manipulating the application itself, right? So we'll definitely gonna visit that in the second half of the training here today. But all of these, every time that you see 10.6.6 or 10.7.7, that is inside of WebSploit. If for some reason, let's say, like MR says, I have a Mac M1, M2, but if let's say you want to download those containers, again, all of them are Docker Hub, then you can absolutely, um, configure your environment as you will. You don't have to do it in a lot of people do that. If they already have like Kali or Parrot in one system, they want to have this isolated in another environment. They download the install script. You're gonna see a Docker compose file in there, or a reference to a Docker compose file. You can build your own environment. You can create your own WebSploit if you want, if you're very familiar with Docker and Docker compose. All right, so let me go back. I am going to combine a few things in here. I'm afraid of time as well. So that's exercise 12. Is basically you getting familiar with them, methodology of using a proxy, and then using other components like the intruder and the payloads, even though you're going to guess a password in their brute force application. But just think about the elements of what the things that you're doing. We're going to do a walkthrough after that, but I'm going to combine that with 12C, which is bypassing authorization. In this case, you're going to be using yet another intentional vulnerable application called UShop. And for this one, I want to take a moment to explain something real quick. Whenever I'm asking here, navigate to account, and then click on login and register an application and not yet a customer, this is a fictitious application. It is not putting your information to anywhere in the cloud. A lot of people ask me that. And then the second thing is that you can put any fake email. As a matter of fact, I think in here, I put omar@omarsucks.com, even though I do own the command, that domain, because I use it as a joke, omarsucks.com. But you can put anything. You can put evil at, phone.com, and then, some password, and then some, answer for your security question. Then just create a user. Why? Because you're gonna mimic what a user is doing in an application, and then intercepting the transactions, adding things to this basket or shopping cart in the application, and try to enter into somebody else's basket. So basically manipulate and take advantage of authorization, broken access control, which is what we were mentioning yesterday at the top of the list in there. So you're going to be learning about that one there. It should not take you that much. Probably intercepting the transaction is going to take you the most, and it's few seconds probably. Then for the discover the scoreboard, that one, I'm giving you the answer anyways. Is slash scoreboard is one of the things in there. But the reason that I'm having this in here is because I want you to see that OAS UShop is like a mini capture the flag type of environment, right? Just like the ones that I have created, that are intermediate to advanced. This is more of a beginner to intermediate. They have different exercises, different flags that you can find, and you can find these vulnerabilities. Some of them are very basic, just like the ones that you saw here, and some of them are pretty complicated, right? So there's a mix of everything. Just UShop, just this application is has been used in conferences and universities and everything, and in some cases in 3-day boot camps, 3 days just in this application. So we're scratching the surface of everything that you have available within your environment in there, right? But once you complete that one, then I'm gonna combine exercise 13. That's actually reflected cross-site scripting, and you're gonna start with looking at some of the payloads, and these are the examples of the payloads that I mentioned earlier that you were gonna review. Of course, to steal a cookie, to pop up a window, or be creative, right? These I'm gonna give you the answer right now, so you don't. It's pretty simple. If we're talking about cross-site scripting in this exercise, and then I'm asking what type of vulnerabilities can be triggered by the following string, well, probably, maybe cross-site scripting, right? So that's the answer. But I want you to see the payload in there, right? And the question from PK, which was a relevant question of what about web application firewalls? What about built-in protections in the web browser? This is an example of course, an obfuscated cross-site scripting, and again, you can create filters to look for this obfuscation for sure, but it's kind of like playing whack-a-mole all the time. But look at the examples and the evasion techniques that has the link to what I was covering just a few minutes ago. By the way, within Websploit, all the GitHub repository elements, so basically the whole repo is cloned under root hacker. So whenever you install Websploit, basically I clone the repository that we're getting all this information. So if later you're gonna see examples of code, actually yesterday you saw in some of the exercises, some examples of uh, Python programs that you can create and so on. You don't have to copy and paste from a PDF. I will never do that to you. That's why I put the whole repository and all for your ability to be able to get that under root hacker, just like it says in there. And I mentioned that several times in the lab guide from yesterday and the one that we're going to revisit a little bit later here today. So please complete. I'm going to give you a few minutes for those of you to kind of catch up, but please complete also to the full extent exercise 13. I know that it's super fast paced. I'm going to explain a few of these things later in more detail, but we're playing against time here. So I'm going to give you 15 minutes. And then once we come back, I'm also going to go over relatively quick path traversal, SQL injection, and so on, and then highlight a few things from your lab guide to enhance that learning. So have fun. We'll talk back in 14 minutes and 47 seconds, and I will be monitoring the Q&A panel. If you have a question for me, please do so in the Q&A panel to be able to track it. Thank you, and I'll talk to you then. All right, there's just a few seconds left in that timer, so let me start sharing my screen real quick. And a few things, just because time, and I want to make sure that we cover the three big labs for today. I'm gonna go very quickly and kind of walk through, again, for most of these labs you don't even need me because I documented everything for you step by step, but at least I want to highlight a few things in here. So the next set of exercises that you had allotted for yesterday, again, we're still going to the material from yesterday. Um, they basically expand into the concepts of course, cross-site scripting. So exercise 14, it is around stored cross-site scripting. And in this case, what you're doing is you're putting a payload. It is a lame payload in here. If you see, you're still using the same web application that you used before, DBWA. And then you can be creative. I put this here, be creative, like remember some of the payloads that you learned earlier today for obfuscation or for stealing a cookie and so on. Feel free to use them in there. But what I want you to also understand is that after you navigate out of that page in DBWA and come back, you will always get the results of the of that payload, right? So in this case, popping up a window says Omar was here, but it can be stealing a cookie, redirecting to a website, and so on. So that is a main difference between stored and reflected cross-site scripting, and why stored cross-site scripting is a lot more severe, right? Because in that case, once you actually exploit it once, any user visiting that specific element or the page will be affected. Now, in exercise 14B, we go over a little bit more or other examples, in this case, using the Juice Shop application, right? And as I mentioned to you, of course, that is another OWASP project. Then in this case, you actually are injecting the payload using Burp Suite. So you're intercepting the transactions. So instead of you typing just to the form, now you're getting into the manipulation of specific fields within an application using Burp Suite, right? And I have, again, everything documented for you. Then the next section is XML external entity vulnerabilities. And as a matter of fact, I have a quick write-up on that, and I'll go back to Patch in a second. But XML external entities are vulnerabilities that occur whenever you have a poorly configured XML parser that is evaluating external entity references. And you may say, oh, nobody's using XML anymore. Most people are using JSON and so on. Well, think again. Thousands of applications still using XML, and will continue to use XML in some cases. And these external entities can be manipulated for disclosing internal files using the URI handler. You can also use it for internal port scanning, code execution even, and denial of service attacks. So it can be pretty devastating depending on the implementation. So in your lab guide, we look for that again. I walk through that scenario, and then the application that you're going to be using is WebGoat. And remember that is 10.6.6.11 or 8080, and then you do have to type /webgoat with W uppercase and the G is uppercase. And then basically from there, it's walking you step by step, right? The first few tabs in here, it walks you through the same explanation that I just did to you just now. And then once you go to the exercise, basically you're manipulating a fictitious application that looks like a forum, or it can be something like a comment in Instagram. It can be something like any other social media site, a news site that allows you to enter some input. It is, at the end of the day, input validation. All these that you're visiting here and more, there's a lot of input validation problems, right? Cross-site scripting, cross-site request forgery, server-side request forgery, XML external entities, SQL injection, all that is a lot of input validation, right? Now, whenever you come here, you're gonna, of course, use Burp Suite, intercept the transactions. Again, I have everything with annotations here for you. And then what you're doing is you're changing the XML um, um, markup, because it's not code. XML is not code, but you're manipulating the XML content. And then I put here, be creative. Of course, you can potentially retrieve different files within the system if the application is susceptible to XML external entities. So in this case, I am going over, let me make this a little bit bigger so you can see. I am going over and putting doc type foo, you can call this anything that you want, entity XXE, you can also call this as you want, but I'm referring to an external entity that I'm naming here, and then I'm doing a system call to then list all the files that are in the root folder, not of the web application. We're bypassing that for the root folder of the file system. And then if I'm successful, of course, I'm able to actually see the directories and so on. And then down below, I'm actually putting the comment. And then, here I'm just putting Omar was here and appending XXE. So this XXE is what we call out here. So if you are creative and you name this something else, make sure that you're referencing within the actual comment itself, because that's basically the reference to the payload that you're creating here. So make this smaller again. And then basically you forward that to the application and you are able to see the files and the directories of the file system, and just like you're seeing here. Now, you can try this again. And then instead of you just doing file, you can do etc password and even get the password file. And yes, you were going to be able to do the password file. You will not be able to do the shadow file. And this is why. Because the application at least is not running as root. But many, 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 many people, including even those that are creating code and implementing things for the new AI driven applications nowadays, are introducing a lot of least privilege deficiencies. Well, what does that mean? Well, hopefully you're familiar with the concept of least privilege. This is one of the basic one-on-one security concepts, that you should not give an application or a system or a user more permission that they need to have for carrying out their operation, their work, in the case of a user, and so on. So that is a basic one-on-one concept that you learn in any basic certification or any basic security training. Well, many developers, unfortunately, because we're lazy in the concept, the proof of concept phase and the experimentation phase, they become lazy and they give too much permission to the applications. And whenever they put into production, they forget to to actually modify the permissions and so on. And many applications, believe me, I have seen so many of them, even in recent weeks, that we're still giving too much information, too much permissions. And nowadays, whenever we talk about newer implementations like LangChain for retrieval augmented generation, and actually orchestration libraries, doesn't have to be only for retrieval augmented generation, but things like LangChain and Llama Index that you can create agents, a lot of those are running with too much permission, and where it is not about a user is putting a prompt to a chatbot, but now if you're going towards the more relevant use cases for AI, which are beyond a chatbot or beyond a copilot, that is action-based, that you have agents that are doing this, we're giving a lot of permissions that you should not give to those agents. Same thing going back to this web application. In this case, it was running not as root. If it was running at root, you're one vulnerability away from a complete compromise. And then I can get your shadow file. I can get any files from your system, can crack your password, and it's going to be a complete compromise. So whether you're doing a traditional web application, or you're actually implementing these newer implementations nowadays, You have to follow these concepts, and this is a perfect example of where things can go wrong if you give too much privilege to an application, because then the attacker can absolutely completely manipulate the system. All right, so the next section is about SQL injection. So SQL injection, it is another input validation vulnerability. And this is whenever an attacker is able to inject their own SQL statements to potentially delete files, modify records, or not files. Well, it can be files too, because if they're part of a reference to a database, but delete records to the database, get the records, get unauthorized access to data, or modify the records in the database, right? And this can be done in many, many different ways. If you're not familiar with SQL, then I have here a super brief summary and a section that will walk you through, or different links that will walk you through different sections of on-demand trainings that we have here, the books that I mentioned yesterday that we get access at, here in O'Reilly, specifically the PenTest Plus book. So again, we go into a lot more detail, and because of time, I'm not going to be able to do that. However, for your lab in here, I first start with the WebGoat OWASP, application, and it goes over the concepts. Again, it talks to you about what is a SQL database. You play with a SQL database. You put some SQL statements. I gave you a summary in the top in here, and then once you go through the actual exercise, or the tab number 9, that's whenever you start going over and seeing examples of cross or SQL injection attacks. Right? I think I said cross-scripting, but SQL injection in this case, right? So if you look closer to this very, very basic exercise, but it actually defines the concept of SQL injection. What you have is a database that has a table called user data. You see right there. And then think about that this can be a form in a web application that you are able to search information for somebody called John Smith, right? And in that form, whenever you put Smith as the last name, you see here the last name element. Down below is a gamified option to select what may be the vector and the payload for the SQL injection attack. So think again that this is a form. Somebody's actually typing Smith. What if you actually can do a single quote that you see here? Let me make this a little bit bigger too. A single quote, and then this OR is basically a SQL statement, a Boolean SQL statement that is saying, give me the record for Smith, and then now I'm injecting or 1 equals 1, right? And I'm going to explain why that, that specific option and not the rest of the pull-down menu. But 1 equals 1 is true, right? Number 2 itself equals true. 3 equals 3 is true. 100 equals 100 is true. It's basically saying, give me the record of Smith, or true, basically give me the record for everything else. And the reason that you're seeing this somewhat gamified is, they want to make it kind of like a little game here. You see a little single quote right here. So, down below you're saying, okay, single quote, put in my Boolean or statement, 1 under single quotes, and then equals another single quote, and then 1, then leave it open. Again, you can figure that out in 2 seconds, just by looking at the different options in the page. But at least I wanted to, for you to see the concept of, putting a payload after basically escaping with a single quote, putting a payload of a statement, and then retrieving records from the database. But then down below, I have a whole bunch of additional examples. Then we go over into a lot more like intermediate base. This is actually a record of a user called Chris. Now you're going to be going over the application called UShop. And now we're actually saying in the registration page, or actually the login page rather, I'm putting another Boolean statement, but I'm putting here deleted as is null. So basically that even though the record was actually, or the user is no longer active, the user is not deleted, and I'm actually able to then log in as that user in GShop, right? Then after that, exercise 16 allows you to learn about automated tools like SQL map. So first, you actually go back to the DWA, you put a username in there, you capture the GET request, you don't modify anything here, you save it to a file, and again, all this is step-by-step documented for you, and then you use a tool called SQL map to read that request, right, the one that you actually saved, and then the tool will automate the process. It will have a whole bunch of payloads that actually will go. Some of them you're gonna recognize, like the OR statements, and then there's an error base a payload because it's actually trying to cause some errors to determine whether the application is giving back some juicy information to understand what is the type of SQL database that is behind the scenes, right? So you see some concatenation and invalid SQL statement in there. That's the error base. Time base is basically putting things like sleep, and you see here the sleep F5, and then union query is another technique. And you see this, that the tool is actually doing that for you. And what I want to highlight here is outside of the lab, outside of the tools, the cool tools that can automate this, really fast for you, look at the output of the tools. Try to, in order for you to actually truly learn this, try to collect packet captures, try to actually truly understand what the applications do, right? Again, vulnerabilities will come and go, they will get fixed, they will, applications will change, but that methodology and truly understanding what is the flaw, the underlying flaw of these vulnerabilities is crucial. It's crucial for you to be a good ethical hacker, right? So again, all this is step by step and so on. So I'm going to pause for a second. There's a couple of questions that I've seen popping up in the screen or in the Q&A panel. One is from IA regarding least privilege. Does it matter if the application is running as root inside a container, for example, Kubernetes? And the short answer is no, right? Everything can. There are protections, and as a matter of fact, this. I don't want to sound that it may some kind of marketish or anything else. Yes, I work at Cisco, but just as a reference, yesterday we announced this thing that is a future of firewalls, this distributed thing that is the play is because of a company that we acquired called Isovalent. But outside of that, forget about Cisco and the companies and so on. The concept of eBPF. eBPF is a concept that you can actually even program the root, the kernel of a system, and there's some protections in there for least privilege and so on. But at the same time, in some cases, if manipulated, an attacker can then get complete access to the thing. So it's a dual nature of elements. So many people say, oh, if things are running in containers and it's running in, as root and so on, is that something that is safe to do? There is a little bit of components, but running containers as root is another issue. Right? The container as a whole as root and the application as root is another issue that should not be done. Right? There are many different guidance from many places, from Docker, from Kubernetes, and so on, of rootless and least privilege implementations of containers and applications running in containers. So short answer is no. That was a long answer that I just gave you now. PK asks, is SQL injection a vulnerability in RDMS systems in general or web apps that connect to those RDMS? Is it safe to use DB1 like Oracle and DB2 like MySQL, or does it matter at all? At the end of the day, it's an input validation vulnerability in the web application itself. The mitigations of this is use things like parameterized queries and everything else. It is regardless of the database. Now, in this case, we're using MySQL because it's free and it's part of the exercises in here. But it can absolutely happen to Oracle, NoSQL databases too, and so on. As a matter of fact, in my GitHub repository and also within Websploit, I have other payloads and examples of NoSQL injection as well. So really good question. Okay, thank you for that. All right, so I know that was like super fast, and then I have a section here for exploiting weak cryptography and so on. What I want to do is at least go back. Let me close the lab from yesterday, but at least go back and explain one more concept that I skipped, and very quickly, and then shift gears to today's material. I'm gonna at least get you started in the lab guide, because I think I'm gonna look at the time and have make sure that I want to address your questions, and I give you time, but I'll give you a lot of this as homework as well. So the last concept for web applications before we go over, again, there are hundreds of web application vulnerabilities. I'm highlighting just a few just to get you started. But another one is file inclusion, directory traversal, other people call it path traversal, and so on. And this is a very old attack that is still happening nowadays, because it's still the input validation, type of problem and sanitation and so on. But this is whenever an attacker can manipulate a system or web application to then escape out of the web root folder, similar to what you saw with XXE in our example. But in this case, by just putting dot dot slash, and of course you can encode that type of payload in many different ways in the file path, and then you're able to access arbitrary files in the system. Yet another example of why running applications as root is an issue, because even a simple vulnerability like this can lead into the attacker obtaining, tons and tons of sensitive information from the system. So that's another example of course, a web application vulnerability, and then how attackers can actually change that and even manipulate the system if you're not running the application with the correct permissions. All right, so that is it for the material from yesterday. The material from yesterday. Let me close that one. And where's my other lab guide? Don't tell me that I closed it. Yes, I did. Bear with me a second. All right. So what I'm going to do, just to get you started in the lab guide, and then once I give you the break to at least get started with the lab guide of today, I'm going to come back after the break and start covering some of the concepts of how to build a lab for networking hacking. What are the vulnerabilities in network? Why do you manipulate network devices? How is that evolving? And so on. And then a little bit of information about SQL injection, not SQL injection, about buffer overflows and fuzzing and payloads, and how to create your own payloads and so on, while you actually walk through the exercises. So first, I'm going to give you a break to get started, especially in the reconnaissance section, and then we'll go and cover some of those topics after the break. So this is the lab guide that was allotted for today. It is available in the resource section. So in the bottom of your screen, you will see the resource icon. It is available there. You don't have to actually follow that link that we posted. Those were for the lab guide from yesterday for the folks that were not here today, right? Because I know that some of you were not here for the folks that were not here yesterday, and you can get access to them, because I know that some of you probably, join us today and you were not here yesterday. You do have, full disclosure, a lot of things to catch up, as you see. So in today's lab guide, I still go over the introductory material for those of you that were not here. So what is Websploit? Some of the background information about Websploit, the containers, how to get access to the containers. Hopefully everybody is familiar with that, right? and then what ports are used for the web applications, all that type of thing. Then in here, I refresh, again, for the people that were not here yesterday, a little bit of the open source intelligence, but then, and especially about collecting packet captures and obtaining information from things. So it's a little bit of both, active and passive. And then we start going over these hacking DC 3101. So I am the lead of the DEF CON Red Team Village. DEF CON, if you don't know what it is the biggest hacking conference in the world. This year is going to be huge because the White House last year gave some funding, a lot of money, for a competition about AI. So, if you are planning to go to DEF CON, please stop and say hi. But each year, what I do is actually I release different mini workshops, if you will, and capture the flag environments, and then I put them into Websploit, and it's a capture the flag. Basically, we give a prize, $200 to whoever actually gets it. Last year, unfortunately, nobody got it, so I had to do a write-up myself, and it's actually pretty easy. But DEF CON is so big, so nobody's gonna dedicate a full day for only one exercise or one things. But there are 3 containers, right? 3. All 3, they include very different intentional vulnerable applications. Those containers are these right here, DC31, and DC stands for DEF CON. 31 is the 31st year, and then the 01, 02, 03, so we can at least have some identifier, right? And then those are running in the 10.7 network in a different Docker bridge interface. But you have access to it through Websploit exactly the same way that you were interacting with the other applications. Now, each of those now are going to be running a little bit more difficult scenarios of applications. And you're going to go over from knowing absolutely nothing about a web application. Like in this case, I'm already giving you the answer that, of course, is running Redis, but going over the process of reconnaissance, scanning all the ports. You see that port 6379 is actually open. And then from there, using different techniques, and you don't have to use very complicated hacking tools. The client, like the Redis CLI, can be used for reconnaissance and can be used to obtain information. So in this case, I'm connecting to it and I'm doing info server and I'm getting information about the underlying implementation of Redis, right? And then from there, I'm researching and I'm giving you the information because you're not going to have the time. This is where you see the amount of complexity and time. It's not about the actual complexity of the vulnerability, the research that you have to do. In this case, there are known vulnerabilities and known exploited vulnerabilities, but you have to actually do that type of research and so on. The exploit that you can use for these is in my GitHub repository, so which is within Websploit anyways. But it is this long line and it's doing an eval, and then I am doing a pop open and then basically displaying the ID, and I'm showing that the application was running as root. So this is a perfect example, PK, or actually was it PK? Yeah, no, it was IA that was asking about the applications running inside of a container, blah, blah. This, of course, even if you have like Redis and it's running as root, it has a vulnerability, you're just one vulnerability away from a complete compromise because I'm already root, right, into that vulnerability. Not the whole system, right? Yes, I'm not going into the underlying system like the hypervisor and so on, but the complete environment of that application I can manipulate, right? And in this case, of course, this is a Redis database. But if it was an application that you have access to customer data or I can manipulate the underlying thing to command and control. There's thousands of different scenarios that you can think of. So again, everything is step by step. I'm explaining every single element of that payload. The other exercise is DC31. I'm gonna pause for a second, but I am going to give you a 15-minute break. Just like yesterday, we are not taking separate breaks for bio breaks and so on. So plan accordingly, right? This can be your bio break plus, of course, your lab. But if you don't mind, let's start with that exercise 1 and 2. And once we come back, I already walked you through that, second exercise. So you don't need me for that. But I'm going to start covering some of the concepts of networking and so on, give you some references in there for people to catch up. Because 15 minutes are not going to be enough. And then once we conclude that, then we can shift gears into buffer overflows. And then after the buffer overflows, we go over the second container here, the second application, which is a lot more complicated. So let me start that timer. Please feel free to continue to ask questions in the Q&A panel, and I'll talk to you then. Have fun. All right, the timer is over, and here I'm gonna start with a few of the slides that we have allotted for today, and then basically the question that I get all the time, so there are a lot of attacks against endpoint machines and so on, and of course, networking devices, present a pretty big challenge because if you compromise a network device, you can do a lot of things to the underlying systems that are connected to the network. But what is a network, right? And whenever I go to networking devices in here, I'm talking about virtual or physical routers, switches, the firewalls that are supposed to protect you, and so on. The infrastructure that is in the cloud, all of that is included here. It is not about just a router that is in physical location, and so on. It's either hardware or software infrastructure. Now, why hack a network? Of course, they can be used as a stepping stones. They can use for mass surveillance. Sometimes they're not monitored as close as your host, and they definitely have a longer system life cycle. That's one of the major problems nowadays. A lot of people are running infrastructure devices, and I'm talking about a lot, and a lot of companies are running infrastructure devices that are end of support for many, 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 many years. And you see them in the news every day, right? There was an attack or a campaign called Volt Typhoon by the threat actor that is associated with the Chinese, government. It was a nation state type of attack. And they were using a lot of living off the land, which you will learn later in the presentation. But they were also leveraging a lot of very old equipment that is still being running in the environments. And then those equipments, not only they are not patched for vulnerabilities, but some of the runtime defenses, the best practices that are now being incorporated into the modern, when I say modern, is like even the last 10 years, of the networking devices, they did not exist at the time. So of course, they're able to manipulate those and then do a lot of, malfeasance. The other thing is that sometimes, not sometimes, all the time, you're running protocols that are designed back in the 80s that security was not a big concept of it. And a perfect example of that is BGP. We're actually using it right now because my voice is going over IP packets through the internet, then making it to your machine. Of course, it's going to the cloud to 124 and then making it to your machine. Well, all those packets are actually routed using BGP, right? So a lot of these things attackers are taking advantage of. And then even with features that we have within the environment, like port mirroring, tunneling, lawful intercept, they're able to use that to infiltrate and exfiltrate data as well. So you may ask, okay, Omar, how can I play with this? How can do I have to buy a whole bunch of routers, switches, and everything that can get really expensive? And the answer is no. You can use free tools like GNS3 and then put some virtual images of systems or have other tools like Packet Tracer. And in the sliding here, I have a few links there for you. But one that is getting a lot of attention, and it's not free, but it's getting a lot of attention, and it's because people are preparing for certifications, is the Cisco Modeling Labs, right? But Packet Tracer is free. It's also a way that Cisco gives back to the community, and GNS3 is free. But Modeling Labs takes it to a completely different level because you can actually deploy a lot of different infrastructure components really, really easy, and also have the ability for you to put like even web split. For example, I was doing a presentation, a workshop, a full day workshop at NC State University a few weeks ago with a colleague of mine. His name is Chris McCoy, and he put Cisco Modeling Labs for pods to actually have pods for each of the students. There were about 120 of them, and everything was in AWS. We put them in AWS, and we put WebSploit inside of Cisco Modeling Labs, and then we put a really big infrastructure routers, switches, firewalls, etc. And we're going and teaching, of course, how to manipulate those devices. So you can absolutely do that. Super popular for people that are preparing for things like CCIE, CCMP, and so on. Now, what about the attacks, right, of vulnerabilities? There are many of them, right? Of course, every day there's a new known vulnerability that gets disclosed, and associated exploits to, like, whether it's exploit database, Metasploit, GitHub, and so on. That's a given, right? That for sure that's going to continue to be. We're never going to have a system that is immune to vulnerability. But you have also layer 2 attacks of misconfigurations like BTP, DHCP. You can do rogue DHCP servers or um, DHCP starvation attacks. And you may think, well, there's millions of protections against that. Guess what? A lot of people are removing them for troubleshooting because, again, whenever people blame the network, and again, the network can be physical systems or virtual systems in the cloud, um, they forget to actually re-enable that. And that's why we strongly recommend a lot of automation to look that any security best practice in infrastructure devices, even if they're potentially removed for troubleshooting or to isolate the thing or enable, like port mirroring, that they actually go back to a good configuration state. And you may think, well, things like Ansible and Terraform have existed for quite some time. Haven't we solved that problem? Guess what? No. The technology exists. People using the technology and using the correct, templates and the correct processes for automation and increasing the security. That is still less than optimal nowadays. That's why we're actually teaching all these classes, right? So other things like, of course, weak configuration, default passwords, attacks against other features like ASRP or sorry, ARP or ARP cache poisoning or HSRP. HSRP stands for Hot Standby Routing Protocol for um, high availability. Well, an attacker cannot potentially manipulate that as well to cause service attacks or actually take over. Do a lot of different nifty tricks, against the network. Then, of course, you have things like 802.1q for a Q and Q type of attacks and 802.1x for authentication based attacks as well. So again, nothing is immune to these vulnerabilities. Now, let's see, how can we protect L2, L3 in the cloud? Since this is perfect, actually. So PK asked a question that is super relevant in the Q&A panel. How can we protect layer 2 and layer 3 in the cloud, since these are all either platform as a service, serverless, type of environments, or infrastructure as a service, or in this case, we're actually using software as a service, so we don't have access to anything, right? So we're assuming that On24 is securing the environment. That is the shared responsibility model. And what I mean is that if you are putting things in the cloud, your cloud provider, it is the one responsible to secure that environment. Now, you may abstract things a little bit. In the case of infrastructure as a service, you may have virtual environments, and I'm not going to call it just routers and switches and so on, but because there's a lot of different features that you can do networking in the cloud. But whether you actually have that control, and that's your responsibility. If you do not have the control, that is the responsibility of the cloud provider. And what people do instead of actually, you testing or and so on, is that they ask for attestation documents, basically that they will legally sign, that they are following the security best practices that you will expect from an SDL program, from a software or a secure software development lifecycle program. And NIST actually came up with a lot of guidance, and we call it the SSDF. And later, I can give you some links to that. Super hot because right now it's being regulated, right? All companies, all vendors, whether you're a cloud provider or not, you have to actually go and sign an attestation document that you're actually following that. Why? Because if you are the consumer, and whether you're a developer, that you're putting things in, in a Lambda environment in AWS, or buying a Cisco router, a Mac, and so on, all vendors are going to be accounted for security, and that they're following the best practices that are dictated in the NIST SSTF, at least in the US. And then, of course, in Europe, there's another big, even bigger um, regulatory regime right now for the CRA, the Cyber Resilience Act, that is actually addressing a lot of those. So it's a matter of trust. It's a matter of making your vendor accountable, and so on. You do not have control over those. Then PK also asked, there are some pre-built network devices that can be implemented in VNet, correct? Some implementations of IDS, IPS, and other devices. Can you provide more details and inference from your Cisco experience? I cannot, in this method, say examples of Cisco for sure, right? Because I don't want to. Well, I mean, I can give you the examples. I'm not trying to sell you anything. Just like I mentioned yesterday, what we're or today, yesterday we announced, this environment that we're trying to kind of obsolete the IDS, IPS firewall type environment, right? And the reason for that is because um, the way that perimeters and even things in the cloud has worked for some time, it is not yet sufficient, right? So it's a thing called Hypershield, and it's because we integrated technology also from a company called Isovalent, that they also have the created Cilium and a lot of eBPF implementations, and we're actually doing policy all the way to the kernel, and it's a very, very large scale distributed type of scenario. So that's where you're going to see the evolution of these technologies, right? So of course Cisco starting with that, the other ones will follow. You will see that it's going to be a combination of it. But yes, right now you can actually absolutely deploy services that the same cloud providers will sell you, right, for security, for sure, right? And it's not about the only the protection; it's also the logging and monitoring, right? It's making sure that you have both visibility and control. And so many different offerings in there, but again, want to be brief in there for one for time, and second one, I want to sell it like a sales pitch. But the the other things that I get all the time, okay, what are other tools that I can use to test, like an ethical hacker type test, not the IPS IDS systems, right? They are very old tools like DivSniff, Div or DSniff, something that have existed for at least 20 years. And things like Ethercap, Scapy, Metasploit as well. They have packet generation tools. All these are newer tools, but now they're being combined with other elements, even with AI, not this stuff, but automated creation of Scapy um, programs for generating payloads. I'm seeing a lot of research on that right now. With AI. So yes, there's a plethora of things, and it may sound super overwhelming, but just don't think about the tool again. Think about what you're trying to do. If I'm trying to demonstrate how an attacker can actually send a payload to a networking device using OSPF, right, and a hello packet to BGP, and so on, or a hypervisor, um, you can actually use good old Scapy with Python and create your packet. That is actually one of the best ways to learn, because you're going like really, really low. Even if it's assisted by ChatGPT, you can ask ChatGPT, explain to me how to send a DNS packet using Scapy. It will create the code for you, it will explain it to you, and so on. But try to understand the underlying issue. Go outside of the tools. Now, the other thing is about setting the environment. I actually talk about Cisco Modeling Labs. I talk about packet tracer, which is free. I talked about GNS3, which is free. But what else? Well, you can actually put a VM, whether in the cloud or on your machine, put it to run Linux, pick, I don't know, whether it's Ubuntu or SUSE, whatever you actually like, and you and Jeremy Linux, and then you do Linux bridging, net filters and IP tables, and you can convert it to a router, right? As simple as that, or as complicated as you would think, right? Or use open source technologies like vSwitch, OpenFlow to even do a SDN type of network. And nowadays, even implementations, because at the end of the day, it's Linux kernel implementations of the things that are newer that I just mentioned to you called eBPF. And for those of you that are not familiar with it, let me actually do this. There's even, and it may sound kind of a marketish, but it's actually not. It's called the eBPF documentary. Let me do this in here and not play it, but it actually explains how technology is evolving for access control, like firewalls, networking devices, and so on. I'm gonna paste this in here in the group chat again for you to know. And they mention different companies like Intel, Isovalent, etc. But it goes over the concept, the actual underlying concept of applying programmability to the kernel. I mean, going way down, and how the evolution of these technologies that I mentioned to you, like SDN and so on, is evolving, and how you're gonna see the future of security, whether it's the Cisco technology or not, right? I mean, this is besides the case, but the underlying technology itself and how is how it's evolving. Now I mentioned SCP again. ChatGPT can do a better job actually even explaining what SCP is. But really, really quick, it is a Python library that allows you to create packets. It allows you to create pretty much all the packets. You can create your own payloads, your own tools. I have tons and tons and tons of examples in my GitHub repository for your learning. There are many other tools out there like Yersinia, again, other commercial tools. The ones that I'm mentioning here, all of them is open source, so it's free. But Yersinia is open source and so on, that allows you to simulate some of the attacks. But of course, there's many. There are dozens and dozens of commercial tools that allow you to automatically do adversarial emulation against networking devices and so on. Right? So, all right. So that should be enough time for people to at least catch up with the exercises. So hopefully you're listening to me while you actually were doing exercise 2 in your lab guide. But I want to do a quick pulse check. And what a pulse check means is that you gonna get a thumbs up or a thumbs down, not the emojis, but a thumbs up or a thumbs down in the middle of the screen. And I want to just get a feel of if everybody has completed exercise 1 and 2 in the lab guide of today, right? So based on that, I'm probably gonna, give you an extended break, right? Still gonna cover some of the concepts in there, but I'm seeing a couple of thumbs up, coming up. So if you have completed the exercise 1 and 2 of the lab guide for today, please give the thumbs up. All right. So I see. Well, it's almost 50-50. Again, so if you complete it, okay, then now it's about 60-40%. So most of you have actually completed. Okay, so I feel good now. Yeah, right now it's about 75% of you, or 70%. So with that, I'm gonna give you only 15 minutes to start in exercise 3. And in that case, now you're gonna be playing with, this is not gonna be about networking. Again, these are containers, etc. The networking section, this is for reference, but for the second container, so DC3102, that is configuring with the IP address 10.7.7.22. You actually got all that information in the lab guide. You're gonna start by, actually, let me share my screen. I'm not sharing my screen. little bit of time. Should be able to see it pop up in a second. For some reason, I don't see it in my site. And if anybody can confirm that you can see the lab guide, is basically the mmap to 10.7.7.22. And if not, I can refresh my screen, but I don't see a preview of it. And I know that there's a whole bunch of delay between whenever I ask the question and you're able to answer it, so I don't see any confirmations yet. But if you can see the lab guide, just confirm in the group chat. Okay, perfect. I see a whole bunch of icons too, or emojis. All right, so yeah, basically we start by enumeration of or scanning of the ports, and as you see, there's several actually of them open, very very basic in there. But now you're going on to different environments that are present within the application. The first one is a Java-based web server servlet called Eclipse Jetty, and then you start going over the other ports, and you find that port 8081 is actually Apache Druid, and you can get the console access into it. And there's vulnerabilities. I'm not gonna spoil it for you. In there, you can also connect via port 8888 and navigate to services. Excuse me, and get a lot more information about the system, right? So I will go over these after the break, but if you don't mind, let's actually take another lab break. Again, we're not going to take separate breaks for bio breaks, so you can consider it however you want or combine them. 15 minutes will not be enough for you to complete that section, right? However, I'm going to start with 15 minutes, and then I'm going to continue to um, cover the topics, kind of the theory topics of buffer overflows and so on, while people continue, doing the lab. And if not, I know that it's super hard to actually do both at the same time. Feel free to actually look into the material here and then do the lab or the remaining as homework, over the weekend and so on. Again, we have putting so much information. Yesterday, I gave you access to, or at least I pointed you to many other labs that are more extensively covering some of the topics of web applications and so on. So again, overwhelming, but I want to give you as much material as possible. So with that, I'll talk to you in 14 minutes and 12 seconds that we have remaining in that timer. So have fun, and again, complete exercise 3. All right, the timer is over, and let's see here. I'm going to share my screen real quick and at least cover the details of that last exercise. But then I'm gonna go and spend some time on covering buffer overflows, and then I'm gonna give you, guess what, more lab homework. But I'll walk you through, the scenario that we have within Websploit related to buffer overflows. But to conclude in, excuse me, give me 1 second. I don't want to cough here. Sorry about that. But to conclude with exercise 2, so whenever we left off and we adjourned for the break, for the lab break, you saw that we did an Nmap scan. You saw that we had port 888 also open, or 8888, and then that's actually Apache Druid, and basically it is with application that is used with Apache Kafka, right? And in this case, is running not a super old, because at the time that actually I did this exercise, that vulnerability was disclosed that same week. But of course, time progressed, since DEF CON until now. But in versions prior to 3.3.2, there was a vulnerability related to the JNDI injection, or the JNDI, and it was an injection type of vulnerability within the Kafka clients, right? So this is something that absolutely can lead into an attacker manipulating the system and executing Java deserialization chains, so gadget chains that can lead into a potential, remote code execution. That's what we're actually doing here, right? So if you click in, or if you keep going, there was a CVE last year, late in the year, that was actually disclosed, or that was published, or the vulnerability was published and identified with this CVE. And there was a GitHub repository that was in Chinese about this repo. So of course, I can use Google Translate and everything, but just to be funny, I actually use ChatGPT, translated from Chinese, and guess what? It was actually the exploit itself. So I cloned that GitHub repository, then of course executed the Java jar file, and then I put it to a target. Of course, you have to replace 192.168.102 with the address of my VM, which is the 10.7.7.22 that you see below. And then basically, you can either send this post, I'm giving you basically the recipe, in Burp Suite, or use the Python script that I'm basically showing down below, that you will see right here. And all that is in your um, GitHub repository, in my GitHub repository, right, which is in your environment. You don't have to copy paste in that. So once you actually go over, this lengthy Python script, you actually invoke it, and I just named it poc.py, put the target as 10.7.7.22, and then of course in my case will be, the command and control will be 192.168.1.102, but it will be the VM that you have. So whatever the Kali box IP address, that's what we're gonna put in there. And then for the purpose of execution and to retrieve who am I, right? You actually see that I'm able to do or leverage this vulnerability to not only get a shell, right? Because I invoke a shell, or a shell command, but also demonstrate that I'm able to run anything as root. So I got full compromise of that application. Excuse me. So exercise 4, we will get to that one a little bit later. I just saw a pop-up, a question, and actually it was my PK that he had to adjourn. But thank you, PK. I really appreciate the kudos in the Q&A panel. But again, everybody, if you have any questions, feel free to continue to ask it in the Q&A panel. Now, let me actually do something real quick, because I closed it by mistake. Again, I'm doing that too many times here today. Let me go to the slides and cover what are buffer overflows. All right, so what are buffer overflows? This is a fairly lame representation of what is a buffer overflow, but I wanted to go over and at least do a very high level introduction. So basically, a buffer overflow is an input validation vulnerability that occurs in programs written in programming languages that are not memory safe. And one of them, of course, is C or C++, and so on. And this is very painful doing it with my tracking path in here because I'm traveling today. If not, I will have some like fancy, writing instruments that I have in my house with a monitor that I can write on. But I am traveling this week, so I am not Picasso also, so I don't want to confuse. But let's say that you actually put input into a program, and that input in this case is the word hello, and is confined within the boundaries of a buffer. The program will run and so on. But if I actually put more data that a buffer can actually handle, and I do not have any input validation or sanitation to make sure that these extra characters, are handled correctly, there are a few things that can happen. The first thing that can happen is that the application can crash, and you can get a segmentation fault, kernel panic. It all depends on the application, whether it's the actual kernel itself, within a Linux system or Windows, and then you're gonna get blue screen of death, or the actual application itself, right? Now, that's actually the best case scenario. And you will say, what? What in the world are you talking about, Omar? How is that the best case scenario that your system crash? What if this is actually a core router of the internet and now half of Europe goes down? Is that still the best case scenario? And I'm like, yes. Guess what? Because the worst case scenario is that then I can use this L and the D, create a payload, write to adjacent memory, and then have remote code execution. So now at will, I can either bring down your core router of the internet, or I can manipulate that, or I can steal your data, and so on. Right. So buffer overflows are one of the most prevalent um, vulnerabilities out there for quite some time. And there, of course, there's a lot of push for memory safe languages that can avoid these type of scenarios. But they're all over the place still nowadays, right? Even though we're actually going and migrating a lot of programs, and it's easier said than done, from Rust to C. The reason that's that it's easier said than done is not like you as a programmer, you of using ChatGPT or any inference from an LLM to convert the code, is that there's a lot of legacy code in very critical areas of technology, including the Linux kernel, Windows, you know, or routers of the internet, everything, right? So it's gonna take some time for the whole industry to migrate to memory safe languages. Hopefully, with AI soon, the time that will take will be shorter, but it's not gonna be overnight. Right? That is actually something that I can tell you, and hopefully I'm wrong. I am praying and wishing that I am wrong. But it's something that you probably by the end of the year or next year, you're probably not going to see solved. It's going to take some time in the industry, even with AI. But if something actually happens right now, that there's an AI that converts all the code and then tests it and then migrates it, it's not about converting the code, it's actually getting to the systems and upgrade. Just to put into perspective, remember that we're talking about systems that have been end of life and end of support running in critical areas. And I'm talking about water treatment plants, the energy sector, even in the defense systems, and I'm not talking about only the US, all over, right? Actually, to be honest, in the US it's a little bit better than in other places, right? So it is a significant undertaking, but we have to actually migrate to memory safe languages for sure. Now we are seeing in front of the screen is a day in the life of a program, if you will, right? So you have kernel at the top, text on the bottom. Text is actually basically the data that is either read from a program file by execution or by a user inputting into a program. And then you have things like command line arguments and environmental variables, next to the kernel that reside in the memory space with high address, right? So you see high address and low address at the bottom. It's basically the mapping um, of address in a system, and this can be in ARM or x86 and so on. But then you have things like the stack, right, that grows downward in memory from high address space to low address space, and you have heap that actually increases the value, and this is the entity that of course does memory allocation, dynamic memory allocation, and so on. So what if an attacker can actually manipulate the input, send some data in there, and then cause a stack overflow or a heap overflow, and look for this type of overflow conditions, right? Well, let me deep dive a little bit more. What you're seeing in front of the screen is a debugger, one of many. There are many debuggers out there. This one is called Evans debugger. There's one called Oli debugger, another one called um, Ghidra. That is super popular because the NSA actually released it several years ago, and it's free and it's pretty powerful. And there are commercial debuggers like Ada Pro, and Ada Pro is very very powerful, but very 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 expensive, right? So if you're studying, of course, things like EDB or Ghidra will probably suffice, right? Now, in this case, what you're seeing is me highlighting a, a register, and that is the instruction pointer register, EIP. And this is in a 32-bit application. However, um, the equivalent in a 64-bit application will be replacing the E4NR. And this specifically, EIP, is what stores the address of the next instruction to be executed in a program. And the value of EIP is basically incremented every time that we execute an instruction. And that value, of course, will depend on the size of the instruction. But tell me more. Why is this relevant? Well, if I manipulate EIP and I put the memory address in there for, let's say, the calculator in Windows, or a, a function to create a user or remove a user, or add a rule into a firewall, I mean, it applies to pretty much anything, then you can absolutely do code execution and arbitrarily control the system. But there are other registers that allows you to go over the reverse engineering process. And again, I'm going a little bit deep in here, and I know that a lot of you are not programmers, right? And this is where some of you yesterday were asking, do I have to be a programmer and so on? And the short answer is no. But if you're gonna go into reverse engineering, create your own exploits, payloads and some things like that, of course, it's obvious that you need to know about concepts of programming, and especially things like assembly language, right? But this other, and of course, the architecture, which is the one that high level I'm covering here. But here you see another register called the stack pointer register, and this basically it is the address at the top of the stack, and or the last element of the stack, if you will, because the stack grows downward in memory from high address to lower address memory. So in this case, the value of ESP is the lowest memory address of that stack. Why is that relevant? Well, if I combine ESP with other registers like EBP, which is typically set to ESP, I know that is like going back and forth, but typically EBP, whenever you start execution, is typically set to ESP at the start of a function. Then this is done to keep track of function parameters and local variables. So as the memory is allocated and of course the stack grows downwards in memory, you can use EBP to get information about the underlying architecture and the underlying program and so on. And local variables can be accessed by subtracting offsets from EBP. And then function parameters can actually be accessed by adding offsets to EBP. And in that case, you're actually doing some calculation on how much data do I have to actually send on my payloads to actually again be successful to execute memory and so on. Right? So, excuse me. In my GitHub repository, and I'm losing my voice now. Let me go to it right now. There's a section called buffer overflow example. So tons and tons of examples and so on in here. In the README or landing page in here. As a matter of fact, let me actually open it with the bad code.c. Oh, it's about the same. I wanted to get a little bit better color coding so you can see the things in here, but I'll do it with annotations. This is a program written in C, very, very, very basic program. Don't have to be a programmer to understand this because I'm going to explain it in like 2 seconds. In C, you have a main function that is executed, in this case, whenever you run this program. And this main function is calling another function to be executed, and that is called echo. And it's this function right here, from here to here. And this function is basically printing in the terminal window, please enter your name below, and then is getting the input from the user with this scanf and is putting it into this thing called buffer, right? Just name it buffer. And it has an absolute value of 20. Now you may say, okay, so is that the problem with buffer overflows that you have to figure out an appropriate number in there? No, the problem is not that. The problem is that there's absolutely no input validation. You do that by doing input sanitation and input validation, and also by using some safe libraries from C. So a lot of these buffer overflows, you don't have to go tomorrow to a memory safe language. You can absolutely mitigate it with safe functions and libraries and so on with C. But eventually, the best way is of course to migrate to a memory safe language. But anyways, let me get out of my soapbox from there. In this example, basically the program just replies back to you and just say, hey, you enter whatever you enter, in that scanf and the buffer. Now there's another function in the top here called the secret function. And in this case, I actually have Omar's crash-free function. This is a super secret function in here. Well, in this case, if the program is executed and then you are executing the program, you put a whole bunch of characters, let's say a whole bunch of A's, you can crash the programs if it's more than 20. And then if you figure out the address for the secret function, then you can execute that. I have an exercise within Websploit. Again, all this also is in Websploit that walks you through that. I'm going to give you that as homework. We're not going to have the time. At least, it was not planned for today. And also in the practical cybersecurity fundamentals course that I gave you the link yesterday, and later I'll make it available today as well. I have a lot of examples and walkthroughs of buffer overflows. Also here, you can go over a few things like references to learn, assembly, right? If you want to actually go a little bit more deep, I have a few examples of walking you through different concept of assembly language, and then a few, actually not here, but in other sections here, a few references to, there we go, of other buffer overflows. Now, if I go back to the directory listing here, under buffer overflow example, if you click on additional examples as well, there's a website called Exploit Education, and they have tons and tons of other examples, even though they're a little bit older, still very relevant. So they gamify their virtual machines that actually have Linux privilege escalation, buffer flow issues, both in 32-bit and 64-bit implementations, and so on. So definitely take advantage of that. Just going through these VMs will actually probably take you half a day. Right? So tons and tons of content in there. Now, I mentioned shellcode, some type of instruction. Is at the end of the day, a piece of code that is used as a payload in the exploitation of a vulnerability like a buffer overflow. And you can generate your own. As a matter of fact, we go back to my GitHub repository and tell me that I closed it, and I did. Bear with me. Now, if you go under post-exploitation, and we're going to cover this section a little bit later once you complete the last exercise in there. If you go to post-exploitation, I have a section called MSF Venom, and this is payload generation that comes with Metasploit. Metasploit is the one of the most popular exploitation frameworks, among the security community. It comes by default in Kali or Parrot, or depending on the version of Parrot that you put. But the security, Parrot security, it comes by default and it's in Websploit. And I have a few examples on how to create different binaries for command and control. We call that reverse TCP shells and so on. You will learn about payloads, command and control, lateral movement, and privilege escalation, and a whole bunch of other techniques a little bit later in the presentation here today. All right, so let's go back to your lab guide. And this is, excuse me, exercise 4. And in exercise 4, you're actually going to go over yet another container. And in this case, it's using an application called OpenFire. You're going to do reconnaissance. You're going to look into what is OpenFire. You're going to discover another vulnerability in there. So if you want, you can combine that and then explore the buffer overflow section that I had in my repository, the additional examples and so on. But just to be fair with you, actually, we're doing pretty amazing on time, because right now is exercise 4. Let me go back up. The other two, yeah, actually the other two are the other two containers previously, so we can knock those out, probably in about an hour. And then scanning containers with gripe and Trivi. Actually, I take that back. We're not are not perfect on time, but we're kind of halfway there, which is perfect in there. We may even finish, I don't know, a few minutes early, but yeah, I'm gonna give you some time now to complete exercise 4. So that's DC 3103, right? And we bring that timer right now. Feel free to stretch, get a cup of coffee, glass of water as well, and then okay, perfect. So IA just confirmed that the recording of yesterday, it is indeed available now. So you can actually get all the links that I mentioned earlier that I was going to repaste in here. You can get that from the recording from yesterday. And thank you so much, AA. You're amazing. All right. So with that, I'll talk to you in 40 minutes and 35 seconds. Have fun. And again, try to catch up all the way to exercise 4. right, there's just a few seconds left in the timer, and I want to be conscious of time, even though what I may end up doing is I'm gonna give you, this. Of course, the both of the slides and the lab guides are yours, right? So you can, you can adjourn and you actually have them. And you have, if you have not downloaded them, I assume that everybody has. Please do so, now. However, you're gonna get access to the recording and the lab guides and the links and everything, um, as long as you, of course, you have an O'Reilly subscription. But Websploit, the lab guides and everything, again, they're yours, right? So you can complete them over the weekend. You can complete them next month. It is pretty comprehensive, and I know that there's a lot of material. Now, at least what I want to do is, my screen is not sharing. Give me one second. Let me share my screen first, and then go over the that last exercise. Right, it was relatively easy. You're basically just using an existing vulnerability, right? But in the real world, of course, it takes a lot more. Giving you the answers in here, it takes a lot more effort, a lot more research, and so on. So we discussed that we scanned the application, the new container number 3 in there, and port 9090 was open. We opened the web browser, went to the landing page, and it looks like there's this application called OpenFire. OpenFire is basically an RTC server, real-time collaboration server. Tons and tons of folks actually use it for messaging, and of course, it's not as popular as something like Discord and everything else, but it's actually using pretty well-known protocols like the XMPP protocol. Right now, of course, there's a vulnerability that was in the admin console. And in this case, many, many, many years ago, I'm talking about 2008, attackers actually found a similar vulnerability. But guess what? They never fixed the issue correctly. So last year, after we released this, I released this in DEF CON, but it was actually literally around the same week. There was disclosed that 2023 32 35315, that CVE, was disclosed and addressing these vulnerabilities, and there was a fix right after that. And nowadays, this vulnerability is also in the KEV catalog from CISA. What does that mean? Well, that the vulnerability is being exploited by real-world attackers. And CISA, if you're not familiar with it, as a matter of fact, I think I have the link somewhere in your slides, but if you see here in the write-up, the CISA's KEV catalog, literally, if you just search for that in Google, it will take you to this known exploited vulnerabilities catalog, and you can download the list, of course, through CSV, JSON, and so on. But you can also access it in here, right? So, like right now, there's a vulnerability like in Palo Alto, and I'm not planning this. I know that I work on everything, not throwing anybody under the bus, but no software is immune. There's a whole bunch of Cisco, a whole bunch of Palo Alto. Every vendor will have vulnerabilities in here. You see D-Link in here. So these are vulnerabilities that we know in the industry, and CISA is alerting people that are being exploited or have been exploited in the past. So whether it's now or a month ago, 2 months ago, and so on. So those are the things that you need to patch today, like all these Android vulnerabilities, Microsoft SharePoint, Fortinet, Ivanti. You see that, again, it's all over the place, right? It's not one single vendor. That's why I want to put in your head that no vulnerabilities or no software is immune to vulnerabilities or hardware, and that they will come and go, right? But in this case, think about what is actually the methodology for you to then leverage a vulnerability. In this case, the problem was that it allows you to do code execution. You have to be clever into the way that you're going to interact with the application. This is a web application, so probably going to be using a proxy. In this case, I'm using Burp Suite, and this is the payload. Basically, I am creating a user. You see username, Omar, email, didn't put anything there, just put the email. And then a password hack me, password confirm hack me. So basically, I'm creating a password or a user, and I created a password, and then sending create. I'm sending that as a payload to the specific URL that has this problem. Is the user create.gsp, and sending that as a payload with Verb Suite. And then after that, you see that if I go to the admin page, you have admin access to it, right? But there's a new user called Omar. And in that case, that user has administrative privileges. So you have to hover over the user little star in there. Again, just yet another type of vulnerabilities that I want you to actually look at the methodology. Again, the vulnerabilities will come and go, but what are the tools they're going to be using? What are the type of payloads? Why is the payload? What is the technique? Well, in this case, I could have probably tried to execute other things, but hey, what about creating a user that has admin privileges, right? Um, the other thing is the exercises 5 and 6. Those are a lot more lengthy, if you will, right? Actually, we're kind of halfway. Like if you see here, when I'm scrolling, we're halfway there. We're on page 27. Just the lab guide from yesterday was 100 and plus pages. So today it's going to be another 50 something pages. Um, we're not going to be able to cover it. But in this example, you're actually doing reconnaissance, similar tools. We're using the Mmap scripting engine, and then you're getting information about um, the actual application. You see that it's a Git application. In this case, it's actually vulnerable. You're actually going to be manipulated. You're going to create the initial configuration for the application because, again, it's just built in there for you to deploy it and then create the environment for you to hack it. So you just have to, quote unquote, install it, within the container. And then after that, you actually start manipulating the application as such. And again, we're not going to have time, but everything here is step by step with screenshots and annotations and so on. And you can use it as homework. Now, what I want to do, at least with the remaining of the time here today, and also allow you for some Q&A at the end, is go over the fundamentals of post-exploitation techniques and also the fundamentals of creating reports for whether it's a traditional pen test, a red team engagement, or bug bounty. Let's start with fundamentals of post-exploitation techniques. There are tons of techniques out there. As a matter of fact, I'm going to drive these instead of slides mostly through my GitHub repository. So if you go to my GitHub repository, again, links all over the place. We've been using it the whole day today and yesterday. Under the post_exploitation directory, I have tons, as you see, and tons of different tutorials for each of the, as a matter of fact, it's not even for each because there are a lot more, but at least several tutorials that cover the post-exploitation techniques like lateral movement. And you see whether it's doing COM server hijacking in here or things that are related to Windows or Linux, using tools like Bloodhound. Bloodhound is a tool that is they removed this. I think they have, I guess they reorganized the page. But Bloodhound is a really popular tool for post-exploitation and allows you to manipulate a lot of different implementations of Active Directory and Windows environment. So it's really popular among the cybersecurity community. Give me 1 second, seeing a couple of messages in here. Okay, I think hopefully you can still see my screen. But again, yeah, the tons of examples in here. To conclude with Bloodhound, actually, I do have a few references to it. So you see my first go with Bloodhound, and then of course the one that for some reason they reorganized, and so on. This Bloodhound is way more than just lateral movement, but you see other examples using fileless. Fileless attacks is the same as living off the land. Living off the land is a technique that I'm going to go and very detailed in the next few minutes. But at least let me conclude into this bloodhound thing. So it's I'm not putting in your lab guides anything related to Windows, and it's because, of course, the licensing, etc., and so on, to put it inside of, I cannot put Windows inside of the container, at least not yet, right? But the thing that I want to highlight here, and I'm gonna just open my GitHub repository in another window in a different section, but under Build Your Own Lab, I have a section all the way down here for cloud-based cyber ranges. And there is this thing called Purple Cloud. And Purple Cloud allows you, a lot more homework for you, but allows you to deploy a complete Active Directory enterprise deployment, even with a SIM in Azure, right? And then you can build this environment using Terraform, and all this is in a GitHub repository that is linked in here. And it, again, allows you to actually do this. And just this environment, Jason Ronstrom, he's the person that actually created it. He teaches a full week course, sometimes like in DEF CON and so on. So it is extremely comprehensive. He uses Bloodhound, and he uses for analysis, for attack path discovery, for lateral movement. Once you compromise a system, basically um, understand the security weaknesses within the AD environment, the Active Directory environment, by visually mapping different privilege relationships. That's one of the key things in here, is mapping privilege relationships and potential paths that an attacker can actually exploit to then, compromise the whole infrastructure. It actually uses graph theory, not this lab only, but the Bloodhound implementation as well. So if you want to deep dive into it, again, this is some work. This will probably take you another duration, probably within like a week. And that's just one out of many references that I have in here. Now, the other thing that I want to highlight, even though I have two small links in here, is a big element of post-exploitation, and something, let me actually show you here. Living of the land, something that is very, very real. I'm going to give you a couple of resources in here. This one. All right. And I'll paste this in the group chat right now. Bear with me. Just like my wife says, you cannot do two things at once. There we go. So that is the second link, and that one. All right. So what is living off the land? This concept of living off the land techniques. CISA does a better write-up than what I can do, and explain it. You can ask ChatGPT, and you can explain it better than me. However, very quickly, it is using the environment of your compromised system, right? So if you're leveraging a vulnerability in Windows, probably you have PowerShell in there. If you're leveraging a vulnerability in Linux and you have Python in there, let's use Python for some adversarial techniques. Let's use a legitimate binary for some type of adversarial technique. So that's the concept of living off the land. And what you're seeing in front of you that is very real, this was actually published back in February of this year, and it's basically a series of guidelines to identify and mitigate this type of attacks. And if it wasn't serious enough, you would think that, okay, so it will be only the US government, but this is in combination with pretty much every government out there. Australian government, Canadian government, the UK government, I think even Germany participated here, but you see every single agency here, like from the NSA to CISA to the FBI and so on. It is something because there was that campaign that I mentioned called Vol Typhoon. We named it Vol Typhoon, and they use a lot of living off the land. But it's not only about that campaign. It has been used for many years. I have used it for many years doing ethical hacking, a type of scenarios. So to give you some perspective, again, the documents go over tons and tons of techniques and how to mitigate them. We don't have time for going over all that today. However, I want to draw your attention to two resources that I have here in my GitHub repository. One is GTFO. I am not going to explain what that acronym means. Again, I do not make this. Even the government stuff, it is included in the acronym, but it is called like that. It's a really good resource about a curated list of Unix and Linux libraries and binaries that can be used to bypass different security restrictions and then doing living off the land techniques, right? So if you scroll down, you will see that you have from Ansible playbooks, again, a legitimate application, to apt-get, and then if you see down to the right is the different function that you can leverage, whether it's to get a shell, to get privilege escalation, and so on. Like for example, if I click on just ARP, Address Resolution Protocol, in this case, I can do a file, L file can be, some type of file to read, and then I can do ARP-V-F and potentially maybe use to do privileged reads into or disclose files in a restricted system. Then you see things like SUID for the SUID bit set for privilege escalation here as well. Some other examples, sudo. So again, these are legitimate libraries, but with very creative ways you can use them to your advantage, right? That's where this document, which is the first one that I pasted in the link, goes over the identification and the mitigation of those techniques, right? And it is pretty lengthy, as you see. You have things for Windows, for Mac OS X, even cloud environments. If you click on that, they have some references on how to do this with AWS, Azure, GCP, and so on. So definitely a lot of homework that I'm giving you here today. Now, of course, the second link is because the whole story of a Volt Typhoon, so the PRC state threat actor, and again, this is front center. As a matter of fact, I'm doing my good citizen knowledge transfer here. If it wasn't serious, they will not have big red letters in here for everybody around the world to actually pay attention to. These are techniques that nation state sponsored cyber actors are using to attack critical infrastructure, not only in the US, but across the world. And I'm going to go into political aspects, but it's not US only. And it's not because CISA says it or the FBI says it, it's everybody, right? You see the series of governments across the world actually are urging people to pay attention to this type of attacks and how to mitigate it. So that's post-exploitation. Oh, the second one that I just closed, but let me open it again, is the LOL BAS. You will say, okay, is that stands for laugh out loud, right? No, it's living off the land, same thing that we've been talking, binaries and libraries, right? And similar to what you saw before, keep going. Oops, not here, it's right here. So similar to what you saw, excuse me, with the GTFO bins, but in this case, it's for Windows, right? As these are legitimate Windows binaries and libraries. And the cool thing about this one is actually they're mapping it to the attack technique. So the MITRE ATT&CK framework, remember yesterday we covered that briefly, they're mapping it directly to the technique of attack that is being used or that can be referenced for however this binary or library can be used for post-exploitation, right? Excuse me. I'm losing my voice for sure. All right, so in the same directory, in my GitHub repository, I also have a lot of information, including tutorials, YouTube videos, other references to things in O'Reilly, and tools related to command and control. One specifically that I want to draw your attention to is basically this one called the C2 matrix. If I go there, take you to this page, and guess what? It is a Google Doc or a spreadsheet. They say, really, Omar? That's what you're gonna highlighting here? As a matter of fact, you see that there are 3 people using it right now. That this file is not suspicious. It says contains links that may be downloaded harmful software. Yes, because this download or this malware or this not malware, but harmful software, it is command and control that has been used for many years. But you as an attacker, ethical hacker, that means you should demonstrate what an attacker can do. Some of these tools are commercial tools and they're not cheap. Like Nighthawk, $22,000. Cobalt Strike, which is very controversial too, has been used by nation states, including China. All of these, right? Is $5,900. Core Impact is $1,200, or sorry, not $1,200, $12,000, right? But the majority of them in here, you can play with it. Some of them have been created by the government for the community to understand and test automated adversary eliminations, right? So Caldera is a perfect example of it. Now that you know about the MITRE ATT&CK framework, well, you can actually automate the process of not only command and control, but a lot of post-exploitation activities using Caldera. So again, it is a very comprehensive list. I'm not going to go line by line. I just mentioned just a couple because they were in front of my screen, but it's very, very, very lengthy. Many of them are there. Which one should you use? Well, it depends on the things that you want to do. And that's where this spreadsheet is really, really good. It tells you the language that supports, whether it's Python, Go, etc. It tells you whether it has a GUI or not. It tells you what is the payload and whether it will work in Linux or Mac OS X and so on. I'm talking about the payload that will be executed in the victim system, in your target system, in the compromised system. And then what is the type of communication? You can do this over DNS, over LDAP, over raw TCP packets, HTTP, HTTP3, and so on. So if you keep scrolling, of course, you got that type of matrix, thus what is called the C2 matrix. And then whether you have a key exchange capabilities, so encryption or not, even steganography. This stego here is even if you can use images for hiding content for command and control. And again, you can keep going and so on. It gives you more information about it. So if you are a red teamer, if you want to do adversary elimination, even in an automated fashion, so have to be a red team itself, I will strongly recommend for you to navigate. Yes, you're gonna get this type of thing is because it has links that even though there are commercial tools and tools that have been created by security guys that preach this, it's not going to infect your machine. It's just they're used for that, not for infecting your machine, but to command and control others, right? It's the same thing like if you were using Metapreter from Metasploit, right? So again, tons and tons of other references on C2s. Even you can use Dropbox, Twitter as a command and control that has been used for many, many, many years by attackers. And then I have a section about additional privilege escalation techniques, both in Windows and Linux. And actually, some of the Linux will apply to Mac OS X as well. All right. I thought that was going to be a very quick section, but we actually are almost in the bottom of the hour. And what I want to also do is allow for going over some best practices. And let me actually just jump to that in a second. Best practices on reporting vulnerabilities, reading your report, right? And this is pretty obvious and basic and common sense, if you will. But you'll be surprised at the people that don't follow these, especially if you're getting started. In a penetration testing report or a red team report, you must be clear of the outcomes of the test. And I put here in most cases include recommendations. I need to remove these. In all cases, include recommendations and mitigation techniques. That is a value add. Not like I mentioned yesterday, some people just run automated scans and run automated tools and they create a report, said, hey, you have 100 vulnerabilities or 1,000, but they don't give you a path on how to mitigate it and so on. And also remember that the audience will vary. You should always have an executive summary that will be read by executives, by the CISO of the organization, even if they may be super technical. You want to actually get the meat or the core of the findings from a high level for an executive to actually use, and then have a section that goes into a very detailed evidence of what you did to exploit those vulnerabilities, to manipulate the systems, to find misconfigurations, to move to post-exploitations, to do command and control, to exfiltrate data. All that, of course, you can put in the um, technical section. So the stages to career report by the book is so easy. Planning, information collection, first draft, and review. But by practice is less than optimal in some cases, right? Where I see out there. But first, consider the target audience, the knowledge of the reports, the purpose, the responsibility of the authority to even make decision, and also kind of like the. And I'm not talking about here demographics of age and attitudes and everything, but what is the role within the organization? And in some cases, whenever, believe me, I tell you by experience, whenever I have delivered and have done a lot of reports to many organizations, whether it's a bank, a government institution, Cisco, my own company, etc., you're gonna have a little bit of friction between the people that you find the vulnerabilities against, and of course the security team. Right? This is always the case, right? Typically, the people that actually hire you are the security teams of a company, right? The CISO, the infosec team, the compliance team in some cases, and so on. But then the target, of course, is no brand new application that you're putting into the system, and this developing a team, is their child. And if you're calling their child ugly, they're gonna have a fit. Most people nowadays, they are in a different level of maturity than just a few years ago, which is amazing. But and I'm talking about no intellectual maturity and everything, is maturity on security in the way that even if I'm calling your baby ugly, it is for your own benefit to make your product, to make your application, to make you know in our case I'm using on 24, so I'm going to pick on that, to make on 24 better, to make Cisco routers better, to make Amazon better, to make anything better, right? But you will see that, and you have to kind of tailor that depending on the audience. But then report classification. This is very important. This is actually probably one of the most important elements of the report planning. This is sensitive information. Whether you found a low severity cross-site scripting vulnerability or a 0-day that gives remote code execution, or a misconfiguration of an S3 buckets that is actually exposing your intellectual property out there, all this is sensitive information. So a good practice is that in your pre-engagement task, basically whenever you're doing the scoping and the NDAs and you're signing your contract and everything, ask about what will be the marking that is relevant to the organization for the report classification. What does that mean? Well, to mark it highly confidential, critical, blah, blah. Now, nowadays we're using TLP. Hopefully everybody's familiar with that. If not, let me actually do a quick introduction to it. TLP stands for Traffic Light Protocol. You say Traffic Light Protocol, that's like green, yellow, blah, blah, blah. Yes, exactly. What you see here, and even with the RGB representation of it, first, no pun intended. This entity called FIRST stands for the Forum of Incident Response and Security Teams. They have created many different guidance for incident response teams, and even have an AI SIG right now that I participate on. I'm the chair of the PISR SIG in there. It is a non-profit organization many governments and companies belong to. They have created different standards. CVSS is one, EPSS is another one, and then in this case, something called TLP, right? Traffic Light Protocol. And it's basically a way to label documents, whether they can be shared within an organization or not. In most cases, for things like this, you're gonna probably start with TLP red. And in some cases, you actually will ask the organization, can you give me your organization's, marking? Hopefully they also use TLP. Or they can say, okay, for me, TLP is restricted. Or for me, TLP red is super highly confidential _ secret, right? I mean, whatever they, and in the government, depending on the environment and where you reside, or at least in the US, you have the top secret, blah, blah. But in this case, I'm not going to go into the government elements of it. But as a whole in the community, you have these definitions that you see in the screen and these categories. We used to have TLP white. One of the newer changes is, of course, for being more inclusive, we just change it to clear. But red is for your eyes only the individuals that you're giving the report. Again, typically you start with TLP red. But if they have to distribute it, they can change that to TLP amber, and it's basically restricted to sharing to the organization only, right? Now, if it's actually something that then you have to disclose, right? Like it's a vulnerability that you have to disclose in a security advisory, in a CVE, and so on, then that's transition later in the thing to TLP clear. This is going to be public, and disclosed to the community. But this is a good thing to become familiar with, right? A TLP. And I completely forgot to paste the link in the chat. And it's that right there. All right. So hopefully everybody already knew about this, but very, very quick. All right. So distribution. This is more of covering your behind. The type of report delivery, the number of recipients, the number of copies. In some cases, you're even obligated to print it. Yes, to print it. And then sign it and give it to only individuals. Keep a log of it. Right? If you are going to distribute this via email, then ask for SMIME or PGP keys. If they don't know what they mean, explain to them. If it's too much, then explain what is the most appropriate way of you to either upload or distribute that. In some cases, kind of a hint, just recruit somebody internally from your client and say, maybe a project manager that is assigned to the project, and say, hey, I'm going to give it to you, and then you distribute it, and you basically just shift the responsibility, but log that, right? It's going to cover you behind. Should definitely perform due diligence to ensure confidentiality of the test results. Some cases they allow you or dictate you that you have to show in front of them that you deleted everything about that pen test or by that red team event and so on. Now, you are collecting information from the moment that you're doing reconnaissance. If you're not organizing yourself to collect screenshots, notes, activities, and so on, you're gonna fail. Many people use from something like Obsidian notes to a Jupyter notebook to commercial tools like Day2 and so on. It is all depends on your scenario, right? Again, there are commercial tools for this. Day2 is actually one, and I'll make a reference at the end. They have a community edition, but again, just organize yourself. That's actually the number one thing that I mentioned. You will not remember what you did even 3 days ago, let alone if you're actually doing this for a month, right? So don't wait until the final report. Then write a rough draft and then review that draft and of course, distribute it. Use standards that are already out there. Some of the tools will allow you, give me 1 second. But that some of the tools allows you to, or they already come with CVSS, the Common Vulnerability Scoring System, another standard from FIRST, or you can use EPSS. And if you're not familiar with EPSS, let me actually go do that again. I guess it's right there. Okay, closed. There with me. All right. EPSS. If you go to first.org, same link that I pasted, but instead of TLP, just change it to EPSS. It will take you to this page. Basically, it is taking CVSS into consideration, but it's actually using machine learning, and this is way before the ChatGPT thing, for um, predicting, if you will, no pun intended, because it's called exploit prediction scoring system, but to predict whether a vulnerability can be exploited or not. And these are public vulnerabilities. They have an API. As a matter of fact, this gentleman, Michael Reutman, he was actually here with me. I'm in Knoxville, Tennessee this week, but I'm based in Raleigh, North Carolina. He was here with me in a, excuse me, in a series of meetings that we call Offensive Summit. But he's one of the creators of EPSS. And again, what he's doing is actually using machine learning, taking into consideration a lot of different elements. If you go under the actual model itself, it does take into consideration CVSS along with many other things. Offensive security tools and scanners that can tell that the vulnerability may be exploited, or a public exploit that is available in ExploitDB, etc. Then based on all that information, then it gives you potential representations that looks like this. Basically, whether a vulnerability is there's a likelihood of the vulnerability to be exploited. And you see a few of these statistics that are like as of today, Friday, April 19th, right? It actually continuously update of some of the statistics of vulnerabilities that now are being somewhat elevated, that potentially can get or are exploited right now. So you can download the data. There's also an API that you have in here. I created little client for you, and it's because of another class. It's kind of lame, but you can create your own with ChatGPT if you want to. This is my public, if you will, or personal, that's a better word, blog post or blog. Let me paste this in the group chat. I think that I put it there yesterday too, but tons of write-ups, random thoughts in there. But I have one related to EPSS. It's called EPSS checker, and it's also in pip. So basically, you can do a pip install, EPSS checker, give it a vulnerability, and then you can get a score like that. So even if you want to, if you find that a system is susceptible to a specific vulnerability and so on, or you're tracking a specific vulnerability like one, you can use this tool to automate that process. Like if you want to check the EPSS score for, I don't know, this CV 2023 24 236, then absolutely you can actually do that and automate it, put it in a cron job. And if it goes up, then you can alert people, blah, blah. But you should patch anyways, right? But it allows you to have a way to prioritize vulnerabilities. Now, talking about that, we go back to slide here. Oops, there's another element. I don't have the link. Interesting. But anyways, it's called SSVC. So let me give you the link in the group chat real quick, and then I'm going to go to the page. Page first. Put the link in there. And this is yet another method for vulnerability categorization and prioritization. So CERT, which is part of the Carnegie Mellon University's Software Engineering Institute, or SEI, with CISA, created this SSVC system, and it was back in 2019. If you go down below, There's a beautiful YouTube video that actually explains it a lot better than me with a little bit more time. We want to leave some time for Q&A. And then you have different categories, that's the word, categorization, of the decision that you have to actually make on whether you have to patch that vulnerability right now, like that's the act, or just track it, or attend it, at a later point, and so on. And it's in order for you to scale. Why? Because there are thousands upon thousands of vulnerabilities that are being disclosed and found every single year. It's impossible. And I repeat, impossible. So people like me that I always, have said, patch, 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 right? I'm telling you that it's impossible to patch, 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 patch everything, right? So that's why there's a lot of, you know, efforts in the industry for prioritization to make sure that, like, I will always suggest, and this is Omar's personal opinion, not Cisco, not everybody represented here. My personal opinion, I will always start with Kev catalog. If it's already known to be exploited, that's the thing that I should have patched yesterday, right? So definitely have to act, right? And then you're gonna look into EPSS. What is the likelihood of it? But then you can also use SSVC for like that decision tree, and they have a calculator that you see here. And this calculator basically, you can start a decision with a vulnerability, and then whether that vulnerability has a proof of concept exploit or it's actually active exploitation. So let's say it's only a proof of concept exploit, something that you see in exploit DB, but you don't have no awareness of exploitation. Then it says, okay, there's a technical impact. Let's assume that yes. And then is there an impact to the mission and well-being of the company, the product, the et cetera? If it is total, let's say here, and the mission prevalence is essential, and I don't know, the public well-being is material, like irreversible is like, somebody dying type scenario. If you click on calculate, then it will give you that vector, similar to CVSS and so on, that you can even put it associated to a CVE or some identifier, right? Select even a role, and you can export it either through PDF or JSON and so on. So let me actually share with you how that looks. Let's say I am a developer, and I'm going to include the decision tree, and this is about CVE 2024 1, 2, 3, 4, 5, 6. Hopefully that doesn't assist. I click on export, PDF. Okay, should download. I think it's already downloaded. Give me 1 second. Nope, it didn't download. What? Me. There we go. Me is the user, not the machine. So let me open this in a new window here. New. And you get this decision tree, the vulnerability information, and wow, there is. I just put 1, 2, 3, 4, and there is already 2024 1, 2, 3, 4, and it's actually about WordPress. So it was actually even able to extract the information, and then it goes over the full decision tree for it, and so on. So pretty nifty tool. You don't have to do that for every single vulnerability report, but you can enhance your communication to the customer and provide them with these tools, provide references to it, and of course, the mitigations for each other tools. But I just wanted you to become familiar with this. A lot of people are not familiar with it, and so on. All right. It is 43 minutes past the hour. I want to stop here for now and allow for any last minute questions that you may have. And while that is actually happening, or while I'm waiting here for a little bit, there will be a survey that will be popping up in the bottom of the screen. I think that you already have it. It's very important for Riley, very important for me. Please, it will not take you even a minute. Please complete it. Let us know what you thought about the class. And I gave you a lot of homework, tons and tons of references, different tutorials, the websploit. Again, websploit, you completed all the exercises. It will take you a significant amount of time. So with that, thank you, and I'll pass it back to Nurul.
All right. Thank you, Omar. Thank you for sharing your expertise and knowledge with us today on day 2. And thank you, folks, for attending yesterday, today. We hope you've benefited from it, and we look forward to seeing you in another Ready Life courses. Now, you heard Omar mentioning about the class feedback. That is how important it is. At the bottom of your screen, there is a bar chart looking widget. In fact, while I'm mentioning right now, you will see the widget highlighted on your screen. Click on that and let us know your thoughts about the session. Now, if you don't see it still, towards the end of the session when we end, you will see it again, and then you can let us know your thoughts about the course. The recording from today's session will be ready in about 24 hours after we end. You will receive an email with the recording details as soon as it is ready. And Omar, I think we have one more question that you can answer from MR in the Q&A inbox, and then we'll end after.
Yes, and the the question is a little bit. I need to navigate it, but the question is from MR. What is Cisco's position? I cannot make Cisco's position in here, so I'm going to tell you what is my position. Right, that are available for veterans for pen testing. Cisco's positions, like job positions. We are absolutely hiring, and there's actually a lot of programs right now in place with the Department of Defense for onboarding veterans. As a matter of fact, in the official Cisco blog, blogs.cisco.com, you can search for my name. A while back, actually, I posted a few of the programs that we have for career placement for veterans. So definitely, become familiar with that. We are always hiring, not only for pen testing, but other sites. But definitely, we have allocated or placed a lot of veterans in the ASIC, the Advanced Security Initiatives group within Cisco. So thank you for asking that, MR. All right, so I pass it back to you, Nuro.
Alrighty, thank you, Omar, and thank you, folks, again. Have a wonderful weekend, and be safe and stay well. Thank you all.
Thank you. Have a nice one.